Okay, here we go. So this last unit that we're doing is like all random things that we have to do, right? So next year they're making us do a new Algebra 2 curriculum. And it's the same one that they're using in Algebra 1 and Geometry. And so the first unit in that curriculum is the one that we're doing at the end in this curriculum. So we decided to just like save us some work for next year, just go ahead and use like the new stuff for this last unit. So it's a little bit weird, it's taught a little bit different, but we're gonna put it in the notebook. So go ahead and grab your notebooks, fill out the table of contents. If you haven't turned in homework 52, you can turn it in right up here. That's the piecewise one from the other day.
I did it. I actually did it.
I'm so proud of you. You should be proud of yourself. Thank you. I will get it graded. Sure.
Yeah, I mean, I'm missing.
I think I did that right.
Maybe.
But I don't know if I did it correct. Don't stress.
What? When did this get on there? Quiet. You know what's a reminder? It's a fight. Question. Sequences.
So we would never have a cap again.
That's a good question.
Because my cap teacher's leaving, so I want to get a cap again.
When I asked on Friday, they said we would do advisory again Monday next week. But there's still an AP test on Monday next week, and the whole reason for not having it last week or this week was because of the AP test, so not really sure.
We were 3 weeks.
I don't want any crazy.
Oh,
We
geez.
just don't.
So 2 full weeks, 2 days, 3 days.
So wait, it's fine. It's fine.
Correct.
Oh,
3 days is fine.
that.
So this week is an A week, next week is a B week, and then an A day, a B day, 3 days.
I thought we had this week and next week because seniors leave whenever there's 2 weeks.
So 3 days. Yeah, it's good.
What did that enjoy?
Wait, what?
There's 3 weeks.
What?
It's two. Oh,
No, this is the only final I'm gonna pick. So,
That makes me feel so special. Okay, so sequences. You've probably seen things like this before. Okay, so you want these notes right here. It has the weird picture on front called the towering sequence. These are the notes you want. They're gonna go on page 140, whatever we just wrote down, 144. So a towering sequence. Geometric sequences. Okay. Each one, there's extras up here.
What does it say on it?
A towering sequence. Okay, and on those notes, you are going to build a list of 5 numbers based on that rule. Each number is 1 less than twice the previous number. So you can pick whatever starting point you want. And you're gonna make a list of 5 numbers where each number is 1 less than twice the previous number. Okay? At the top of those notes, right under where it says towering sequence, you're going to make a list of the 5 numbers. Pick a number to start with, then follow that rule. Each number is 1 less than twice the previous one to build a list of 5 numbers.
One lesson twice.
Okay, here in a second, I'm gonna have you trade your paper with your neighbor. So you can double check theirs, and they can double check yours.
Okay.
Wow. You want to see Rob, let me see.
I can't wait to the store.
All right, so trade with Cheyenne.
I really pulled Jolly Rancher for that.
No,
Little Jolly Rancher.
So you like have the fish.
Yeah.
You times by two.
Okay.
And then you like-
One
and
more,
then
bro.
you times that.
Yeah.
And then by two.
All right, trade your paper with somebody.
I just got mine.
Oh.
Fish back.
I got 3 or 5. 3 or 5.
Oh. Okay, I'm like, you can't double.
I almost made such a big number.
Mine
I almost made double price, but it was gonna be Sorry.
I know you. There you
All right, Miles, what'd you start with?
go.
20? So tell me what your sequence was.
Sorry, what?
What was your sequence? 20 and
39?
then
6.
77?
153. 3 or 5.
3 or 5.
All right. Who had a different starting point? I guess not everybody chose 20. All right, John, what'd you have?
2. Yeah, y'all had 2, 3, 5, 9, 17.
17?
Yeah.
Jason, what'd you have?
I had 5, 9, 17, 33, 65.
Anybody else have a different starting number? Everybody started with 2, 5, or 20?
No, you started 5.
Which one did you start with? 0. All right, if we start with 0, what's 0 times 2?
0.
And 0 minus 1? Negative 1. Negative 1 times 2 is negative 2, minus 1 is negative 3. Times 2 is negative 6, minus 1 is negative 7. Times 2 is negative 14, minus 1 is negative 15. So that's what yours should have been. So you can fix it. Okay, anybody else?
I started with blue,
With 3.
so it's what we were just saying, so with the front of it.
So this one with what?
No, over 5.
Oh, this one?
It's just
3 in front of it? Interesting. So you notice how these were all the same here?
Yeah.
Do we notice anything else?
That's 3 or 5.
Yep, it's a sequence. Okay, notice all of these that started with positive numbers keep going positive, but this one that started with 0 got more and more negative. What if we had started with negative 5?
Negative 5. 65. I don't know.
What's negative 5 times 2? Minus 1 is,
No, it's
times 2 is negative 22, minus 1. Times 2 is negative 46, minus 1 is negative 47. Times 2 is negative 94. Minus 1 is negative 95. Okay, the whole point of that was to be able to make a list, like take a rule, use it to build a whole list of numbers. You guys did, good job, pat yourselves on the back. Okay, so now we have this thing called the Tower of Something puzzle. I'm just gonna call it the Tower puzzle. It's got a set of discs on a peg similar to this, while there are two other empty pegs. A move in this puzzle involves taking one disc and moving it to another peg, and there are two rules. You can only move one disc at a time, and you can't put a larger disc on top of a smaller one. So you complete the puzzle by building the complete tower on a different peg than the starting peg. Okay, sounds a little bit confusing, but I'm going to show you. We used to do this. All right, so if we start with 2, okay, I need to move this one over here, and then I need to put the whole puzzle on a different peg. So I'm going to move that over here, like that. Oh, I solved it. Good job, me. Okay, so I solved it in 3 moves. Okay. Wow. Here in a second, I'm going to send you this link, and you're going to try and solve it with more than 2 discs. Okay, so you're going to try it with 3 discs, and then 4 discs, and then 5. And you're going to play with it on your Chromebook. Okay? Whenever you get it moved, or if you want to restart, you can hit this reset button, and it puts it back at the beginning. This little toggle moves.
Oh my God.
Holy cow.
Okay? The whole point is to figure out the fewest number of moves it takes to solve the puzzle. Okay? You probably won't get that on your first count or your first try. You might, but you probably won't. I definitely did not. Okay? So grab your Chromebook, log in. I will send this to you in just a second.
I don't think.
It turns out you can I know, but I'm just saying. Oh, shit.
Good job.
Whoa. What's going on? Who's that?
Okay, so while you're working on it, use your notes to answer those questions. All right. Time's up. So go ahead and close your Chromebook. All right, so what was the smallest number of moves we had for 2 discs?
3.
That was 3. What was the smallest number for 3 discs? 7. What about 4? Apparently 15. Oh, you got distracted by baseball.
I was gonna say, 17.
Anybody beat James 31 for 5 discs? No. That's not the question. Jada said she used the solution for 3 discs to help her solve the puzzle for 4 discs. Does any of you have that happen too? Like once you solved it once, did it kind of help you solve it with the next number? Yeah, because once you figure out the pattern for that many, you're just adding one more, right? Is your phone telling you how to do this?
Yeah, it's actually what I'm looking at. I want to see how fast you can do it with 5. 31.
Okay, so 5 discs was 31. Anybody do 6? No.
I tried.
You tried? Do you remember how many?
I didn't actually get on with them. I had like over 60.
There we go. All right. So if there's just one disc, it's one move. 2 was 3. 3 was 7. 4 was 15. 5 was 31. Okay. 6 would be 63. And 7 would be 127. Okay. Without doing the puzzle, how can I get from one number of moves to the next?
Times 2 plus 1.
What?
Times 2 plus 1.
Times 2 plus 1? Exactly. Okay, so if you take this number, multiply it by 2, 1 times 2 is 2 plus 1 gives you 3. So times 2 plus 1. 3 times 2 is 6 plus 1 is 7. Times 2 is 14 plus 1 is 15. Blah, 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 blah. So what would be my eighth number here?
So, 2,
427 times 2? 254 plus 1 would be 235. Right? And you could keep going, right? So keep going, use your calculator, keep going until you get to 13 and see if it really is that 32,000. It is. You
I'm
have
guessing,
to
I
do it?
mean,
yeah, you could
We'll do it.
alright, so,
Oh, yeah, you could do
Google lies
wait,
sometimes.
wait a minute. Where did I write this down?
That's a good question.
We're just here.
There's a whole bunch of space right here on the right. You can write it.
32,000.
32,000.
Not,
You did it?
no.
Yeah, Google that, then. We're just skipping over.
So do 255 times 2 plus 1.
They're talking about like 81,000.
81,000.
No.
8,000.
Thank you. 511. Times 2 plus 1. 1,000 what?
23,
Times 2 plus 1.
2,047,
Times 2 plus 1.
4,095,
Times 2 plus 1.
8,191.
Okay, so Google lied to you. For 13, it wasn't the 32,000.
Wow, that's easy, right? Only 8,000.
Yeah, I could do it.
You have to go to 8,000 moves, right?
Just 8,000.
Just, yes.
Is that my three times?
Right? All right, so 2 vocab words for this first part. A sequence is a list of numbers that follows a pattern, and a term is a specific number in a sequence of numbers.
That's flashlight.
This takes forever.
Term.
I think I did, seriously.
Okay, so right there in all of that blank space on the right side of that page, I want you to create your own rule that is not the same. Okay, so you're not gonna multiply by 2 and add 1, or multiply by 2 and subtract 1. You're gonna pick a different rule and create a sequence of 5 numbers, starting with whatever number you want.
That's when multiply 3 was 2.
Okay, then create a sequence of 5 numbers, following that pattern you just came up with. Go ahead and finish up, and then here in a second, you're gonna trade papers.
Say that.
You can make up your own hand starting plan. Not the free interaction.
I just divided by 4.
All right, so trade papers with the neighbor, and then you find the next term in their sequence. Okay, so trade papers with the neighbor, and you're gonna write on their notes, and you're gonna find the next number in their sequence.
You already told me yours, so I didn't know it.
What is it?
Here's the.
Were we supposed to write down the rules?
It's covered.
You'll go find the
What, bro?
I might add mine.
Okay, trade papers, write down the next number in their sequence.
Oh, right, that's a good number.
I had it wrote down.
That's the easy number.
No, it'd be a random number.
Oh. I guess you can send out as a back there.
I mean, it depends on what your rule is.
Nah, I got it.
It works.
Trade back and check your neighbor's math. Make
Versus
sure they did it right.
Your notes are too large.
Bro, you were wrong, bro. It was like,
You called me a naughty word.
no, I didn't.
All right, that page is gonna go in on page 144 in your notebook. And on page 145, you're gonna get the one that says introducing geometric sequences.
Have 3 months.
Yeah.
No.
Oh,
It
it was my sport.
You wrote like something like,
Oh.
I would have gotten there eventually.
Bro, look,
Sounds like-
just ask Siri for
Which page?
It says introducing geometric sequences.
I would easily guess that, come on.
You gave me 89.
I hope not.
Hey,
It was nice.
I like you know, it was that I don't know.
Okay, on this page, I want you to look at those 4 sequences. So they gave you sequences this time, and I want you to, look at them, do some math, and then figure out what you noticed about all of those sequences. Okay, write it down on a paper, don't say it out loud yet.
I was gonna say.
Don't say it out loud yet. I'm gonna give you 3 minutes.
You have a fraction, was that?
No. you go to the board. Oh, no.
What are you talking about?
And then do second mode, and it'll take you back to that home screen.
Actually, I'm not sure about that. It's literally like. We have basketball. And it's good to see.
Is it?
Yeah.
You sure?
Yeah, just really hard.
Keep looking at it.
Nothing obvious, I never will.
What'd you say?
Maybe 75%.
Guys, don't speak that into the
He
world.
said the making must probably like 25%.
Yeah, now look at it.
Is it?
You're on the right track.
No.
I'm gonna go with what Miles said over what you said, but
Closer to 75.
Oh, Lord.
Oh, cheeky. What is it? It's,
okay, but you guessed it.
was that the first one?
Huh?
Was that the first one?
That's what I heard. I mean, I'm
Really?
the first one to say it out loud.
Okay. Let's go.
Oh, cheeky. It works. I said 25 minutes.
I'm sorry. I'm actually sorry.
Why?
Because that's gonna ruin my entire life.
Really?
Yeah.
It's very dramatic. All right, what's happening on sequence A?
I couldn't tell you, man.
Oh, we don't
Multiplying
know.
by three. Okay, what's happening on part B? Times 4. Okay, what's happening on part C? Dividing by 2. Dividing by 2 is the same thing as multiplying by what?
Let's go.
And everyone's favorite, part D. Miles, what did you say it was?
Multiply by 0.6.
Multiply by 0.75. What's 0.75 as a fraction? You notice anything else about these?
They're sequences.
They are sequences, yes. Good job. Okay, if you notice the first two are growing because they're being multiplied by a whole number. And the last two are decreasing because they're being multiplied by fractions, right? Everywhere we were or dividing, you could write it as a multiplication. All right, so Claire takes a piece of paper that is 8 inches by 10 inches, cuts it in half, and then stacks the pieces. She takes a stack of 2 pieces, cuts it in half again to form 4 pieces, stacking them. She keeps repeating the process, and we're going to fill in the table. Okay, so before she cuts it at all, how many pieces of paper does she have? 1. And what's the area of an 8 by 10 piece of paper? How's that? 8 times 10 is 80, right? Then she's going to cut that one piece of paper in half. And how many pieces is she going to have? 2. And what's going to be the area of each of those? 40. You cut that area in half, right? Fill in the rest of that table. Actually, before you do that, what's going to be my next number of pieces here? We take our 2 pieces, cut them in half. We have how many? 4.
We don't have like negative pieces of paper in there.
Are we?
I don't know.
Okay, what's going to happen to the area of
each one?
I did.
No. It's gonna be a half cut, right? It's gonna be 20. Now keep going.
So you know those pictures?
I do?
Not the, not.
If you have time. I'm trying to give you some time to work on it.
Oh,
You guys. Hey, what's gonna be my next number of pieces here?
What's the area?
After 3 cuts, it's gonna be 8. After 4 cuts, 5 cuts. Okay. What about area for each one? For 3 cuts would be 10, 4 would be 5 would be 2.5. Okay, how can I use my patterns here? Tell me in words, how do I find my next number of pieces? Multiply by 2 to get 64, because you're gonna multiply by 2. What about my next area?
Divide by 2.
You divide by 2, what's, so 1.25. Instead of dividing by 2, I'm gonna say multiply by 1/2.
Would you have zero paper?
I never go to zero.
If you just cut it up, would you have zero paper?
I'm not gonna test it right now. Okay, after this, if you open up that paper on the inside, there's 2 graphs. And it's asking you to graph one of them. The first one, I think, the number of pieces. The next one, the area. So I'm gonna leave the table up here, that way you don't have to flip back and forth. And I'm gonna let you graph them. One of them, do the number of pieces, the other one, you're doing the area.
What?
So you're gonna do 2 graphs, one of them being the number of cuts. So start here with your first graph. And the other one you're gonna use
Oh, so
these numbers and these numbers.
Dude.
Okay, you're gonna plot points, you're not connecting them, just plot those points on your graphs.
How many squares you got up there right now, bro?
It's a word.
I don't remember. Oh. Yeah. I don't remember.
your first graph, you can have it once, 0, 1, 1, 2, 3, 4, 3, 8. Well, your second graph is gonna be 0,
Yeah,
8,
and then-
1, 3, 2. Does your first graph look like that? You ever seen any graphs that look like that before?
Yeah, which one?
Exponential.
Oh, yeah.
Exactly. Okay, so on the graph, the number of pieces is changing with each cut because it's doubling the height of each point, right? It's growing exponentially. We've seen that before. Okay. So this one is the number of cuts. And the area of each piece. Start at 80, 40, 20, 10, 5. Okay, what's happening this time? It's decreasing exponentially, right? Was it 1/2 each time? You've heard those words before? Most of them you've heard Miss Perkins while I was gone. Okay, so, two vocab words here. Geometric sequences are sequences made by multiplying, that's the really important word here, the same number each time. I hate geometry. Okay? And that number that you multiply by every single time is called a growth factor or a common ratio. Again, multiplied. So on those first ones, when we said we were dividing by 2 or whatever it was we were doing, you have to write it as multiplication. So you have to multiply by 1/2 instead of dividing by 2. It has to be multiplied. And that's what makes it geometric. All right. So how many pieces of paper will Claire have if she cuts the paper in half in times? Okay. So what did we say happens with the number or the pieces of paper? Number of pieces of paper? What happens every time?
Divide by 2. Or what's that 1/2? What?
The pieces of paper? I thought the pieces of paper double every time. Right?
Oh, yeah.
Look at your paper.
But you are
She
dividing
cuts
by
them
2.
in half, she gets twice as many pieces of paper, right? So she has 2 to the n power, with n being the number of times she cuts it. Okay, so look back at your table. If you had 2 to the 0 power, that's 1 piece of paper. After 3 cuts, 2 to the 3rd power is 8. So after 3 cuts, did she have 8 pieces? Yeah. So how many would she have? What was the one we wrote in at the bottom? 6. What's 2 to the 6th power? 64. Is that how many we said she would have? Yes. Okay, and the second question, what will the area of each piece be if she cuts the paper in half n times? So she's cutting it in half. That's gonna be the area. So what was our starting area? 80. So she starts with 80 square inches. She multiplies by 1/2 every time for n times that she cuts it. that should be a little bit of a review of what you did in the Perkins. And then it says, why is the product of the number of pieces in the area of each piece always the same?
I'm not getting,
What?
not getting rid of paper.
You're not getting rid of any paper, right? The areas will always add up to be 80. But she's not getting rid of anything. All those pieces will add to give you 80 square inches. All right, on your notes, you're going to complete each geometric sequence. So you're going to find those missing terms and then find the growth factor. You can work with your neighbor if you want. I'm going to give you like 4 minutes. Find your missing terms and the growth factor.
This is a test.
It looks like a lot, but on this, it's not that bad.
Yeah, honestly.
I mean, I think we've done it, it's been hard, right? Except for
Wow.
maybe those equations I just wrote down.
For me.
Check my math.
No.
Actually, you was not being taken care of.
We're-
I think we're someone that you want them all.
Alright, in part A, what was our growth factor? What do you multiply by every time? Multiplying by 2 every time. 6 times 2 times 2, 6 times 2 is 12. 24 times 2 is 48. What's the growth factor for part B? 3. Multiplying by 3 each time. But I can't remember these numbers off the top of my head. 1,080 and 3,240. What's the growth factor on part C? Divide by 10, but we have to write it as multiplication. So we're multiplying by 1 over 10. So this would be 0.21002. What about part D? Yeah, 3 over 1, which is just 3. So it'd be 3 over 7 and 81 over 7. Last but not least, what's happening there? Divide by 2 or multiply by 1/2. This would be 3 and 1/5. Okay, I gave you homework 53. It looks long, but it's really easy. Okay,
Go.
it should not take you more than 10 minutes.
For real?
For real.
Take it back from you.
Okay,
I didn't-